So hello everyone, today we will be solving the question maximum alternating subsequence sum. So the question basically tells us that suppose we have an array, then the maximum alternating subsequence sum means the sum of the even terms of the array minus the sum of the odd terms of the array, and we have to find the maximum alternating sum. So in this approach we will be using dynamic programming. So yeah, so here we can see that the definition is long, so we should use long at every, so I'll define it long as ll so that it's easier for me to write it, and I will also define l, that is going to be the of size size and I'll make a function called solve, which is actually going to uh, return our maximum answer. So approach my here is our my approach here is that suppose there are numbers and we have two choices. Either we can go, no, we do not have two choices, we have only have one choice, so that we can go forward. The choice we have is that whether to include the current item to our uh, alternating sequence or not. So going to ith plus one term is mandatory, we have to do it, but the choice of whether we need to choose the current index, whether it is going to be included in our maximum alternative sequence or not, it's our choice, and we have to write the code for it. So I'll be using a flag boolean to keep track of whether the sign is changing or not, because whenever we skip the number, so our sign is not going to change. For example, suppose we are in the odd index and we skip it, so next index is going to be even either way. Before, if we were to go to next index, it will be even. Now we skip and we will go to the next index, it will be either even. So when we skip it, the sign doesn't change, but when we uh, take it, so now currently suppose we are in odd index and we take it, so our next index should be a even, that is we are going from odd to even, which means that our sign is going to change. Therefore for the take we have to flip our boolean from true to false or false to true. So yeah, this is the logic for it, and let's code it up. I'll make a function called ll solve, which takes first of all, of course, our vector as input and an integer. No, I'll take a index here which tells where we need to jump, and a boolean flag, let's call it flag, which determines whether we need to change sign or not. So yeah, let's make a base condition, that is if our index goes out of bound. So why is it? If index greater than equals to n, then we are just gonna return 0. And now let's write our definitions. So what the skip means, we go to the next index, that is I dx plus 1, and we keep vector as this, and we do not change the boolean, it remains as it is. And now we need to solve for the take, so we need to add something to take, which is actually going to value, that is nums of IDs, that is the current index. And suppose our flag is false, which means we are going to in a take position. So if flag is false, then our value becomes -1. Why? Because we are subtracting. It tells us that we are in a odd position, that we need to subtract it. So let's uh, initialize it. What happens here? We move to the next index, idx, and num side assets. And here the important part is the boolean flips. True becomes false because we are changing the uh, sign from plus to minus, and we are just gonna return max of skip and take. Now next up, let's return the solve here. Return solve will start with 0 and true. Let's see if it works. This is a basic recursion approach. We will memorize it later. Okay, the time limit exceeded here. So I'm going something doing something wrong here. I believe. Okay, the thing that I was doing wrong here, that I didn't jump to the next index here. For example, I was supposed to, here I jump to the next index, just like that I was supposed to jump here also. So now it was going to an infinite loop. Now it will work, I believe. So I'm just getting 0 0 0 here. Maybe I think there's some initialization issue. Let me check. Okay, I was making an important mistake here. So whenever we take a whenever we take a index, so we are supposed to add the current value as well. Then if we don't do it, then our answer will always be the initial. So it's very important that we should add the current value as well. Yeah, so it worked now. Now let's try to submit it. I think the time limit will be exceeded. Yeah. Why? Because this is a recursion approach and the approach is very 2k power n power something. So let's use memoization. So I'll make a sorry size 10001, and I'll make it 2. This 2 stands for 0 and 1 for boolean, and I'll make a if condition here, that is if t of index and flag is equals to -1, then we can just return uh, this. I'll copy it, this only, and you can just return this only, and I'll name it to this to as flag, and at the end we are just gonna make a meme set which is named t. Every value initially is -1, and size of t. I believe this will work for memoization. Yeah, it worked. Let's try to submit it. So yeah, it works. So the approach was simple: to go to every index, and we decide whether to put that index into our maximum alternating subsequence or not, uh, and then we jump to the next index. So yeah, this was it. Thank you for watching this. Bye.